All right, so what do you think is a good or bad resistance in ohm reading on a contactor coil? How do you know if it's shorted out? All right, it's Friday. I thought I was just gonna have follow-ups today, which I kind of was hoping for, and got a call for a hot area. I'm not sure which AC it is, so we'll get down and check it out. They've had a lot of issues here. It's an old building, so it's they've had broken wires. They've had units that I know have bad Cormaxes. A lot of them, or half of them, are not worth repairing, but we'll see how that goes. They're gonna need some new units there, and they have a couple of new ones too, so we'll see what's going on with what area it is and if it's one that I've worked on before. All right, we got a popped transformer. So we're gonna do the usual. We're gonna disconnect power. The disconnect looks shot too. And then go through and make sure if there's a short. So it's gonna be some sort of low voltage short. So I gotta make sure there's no rub outs. This one is fairly new, but did not age well. So yeah, I'm more than sure this has like one of those DC motors, and we have to replace that immediately after it was installed. Another company installed it. And then we're gonna also check the contactors. That's a super simple one that if you don't have resistance on your coil, if those go bad, then you get shorts too. So let's check it out. All right, so we turn off power. I'm getting this confused with another location. This one's still intact. There was one that was burnt up and it was pending a new disconnect. So like I said, new unit, I'm pretty sure that was reused. So we have cut off power, and let's make sure our voltage is fine here. So we have about 240 across all of them. And man, I haven't worked on this in forever, but I guess I had missed this. Somebody put 208 and we needed 230. So before I forget. So I couldn't really show, but I took off the plate, the whole thermostat off the plate. That way that's not making contacts between any wires. There was a cook over my shoulder, but right now we're gonna check for a ground. So to each one, I don't have anything grounded. And then I'm gonna pull these or check across each one and then make sure we don't have any wires touching. That shouldn't be. But checking it to ground is the best bet. Now we're gonna check our contactor. I'll check the coil. Okay, these were about 5 to 6 ohms, which is okay on a 3-phase 30 to 40 amp contactor. You guys are doing the, you know, the 2-pole, those are a little different. Those are closer to 12, 13. These I usually get on a new one like 7 on the ones I use. This one 5 to 6. All right, don't mind the mess in the back. Anyway, I have contactors here, and I just want to show you guys what readings we get on the coil, because student of HVAC over on his TikTok had asked this question. He does like diagrams and little I don't want to say they're how-tos, but they're, you know, they're like you know, checking voltage, checking resistance, the flow of different things. You know, the little diagrams and visuals that he does and he posts on his TikTok. So, you know, check him out. Student of HVAC. He's on, I think he's on all platforms. Just search for student of HVAC. So he asked a question about what's a normal coil resistance that everybody gets, or what they seem or deem to be good or bad. A lot of the, I guess the majority was, you know, 8 to 12. So if you check on your coil side, I want to say for the most part that's a good answer, but it's in his comments he had a lot of variety. He had a lot of higher numbers. Of course, less is bad, but I've actually seen 5 to 7 or 5.8, 6, and those are still good. So I don't know the science behind it. If because some people were saying that it pulls 3 amps if you're under 8 ohms, which I'm not sure about. But some transformers, like the ones I've seen, you know, it's gonna vary on amperage and voltage, because I also deal with walk-in coolers and freezers. So those are 208 120 volt coils, and yeah, like the transformer that I worked on in this video, the transformer doesn't trip on 3 amps, it trips on 4.5. So they're all different. You'll get familiar with whatever you see the most, and a good way to test things is like when you take the old one out and you're going to put a new one in, always check what the new one, what it's reading. Check the coil on a new contactor, that way you know for next time if you don't know these things. So we're going to check resistance here. So these should be bad for one reason or another. Let's check them out. These are, I want to say, 3-pole 24 volts. So let's check the resistance on this one. So this one is 400. What is this one? Okay, you see this is a 208 coil, and we had 400 resistance. Now let's check over on this one. This one is a 24 volt one. We have OL. So those are bad. I just wanted to kind of see what readings we got. This is a 40 amp 24 volt coil. This one is used, but it should be in working condition. I think it was just changed out as a precaution for other repairs, and I saw it there at the shop thrown. And this one is 5.8 to like 6, and that's what I was getting on the ones that I checked, and this is the same exact contactor. And that, or the unit that we had in this video, they both read exactly the same, and then this one read exactly the same. So I'm going to assume that that's normal for this contactor. This is a Homer. I could have sworn this was Eaton, but it's a Homer 24 volt, and this one is 2535 on the amperage there. So, you know, that was normal for that brand. So let's pull in a, now we have Hvacr, that's what they carry here. I'm actually trying to get a different brand, but I haven't been able to go to the other supply house that we shop from. But here is a Hvacr. It's a 40 amp and then a 24 volt coil. So on this one, we still don't get 8. We get 7.8, which is usually what I get for Hvacr for this kind of coil here. Now let's go over to a walk-in cooler that might have, what is this one? It's a 40 also, and it's a 208 coil. You go here. You have 800, right? Then you go to a 2-pole, and this is a 30 120 coil. But now we're dealing with 2-pole. You go here, and you get 385. See if I can do it like that. So they're all different. It's just whatever you're used to seeing Like I said, when you buy new parts, test them so that you kind of know what the range is for parts that you're putting in, for contactors that you're putting in. They're all going to vary, especially on the amperage and the coil voltage. Like I said, these were good at 5-6 ohms, but that's for that brand, that's for that rating that it had on there. For Hvacr, it's a little bit different. So I wouldn't go by a specific rating. I would just say if there's little to no resistance, like under like 4, 3, something alarming, you have a short. Easiest way is just to disconnect that coil, remove the wires from that contactor that you find suspicious, and then start the unit. And if it doesn't trip, then that coil is bad. And if you put it back in and it trips, obviously it's bad. So just want to show that before people were saying like, oh, those are bad contactors. That's normal for that particular brand or unit. And since I reset that unit, that transformer, and just repaired or removed some of the extra wiring that wasn't needed, it's been a month and a half and it hasn't tripped again. So I doubt those contactors are bad, being at 6 ohms. All right, so on the AC call, I came down and I started talking to the manager, and I kind of stopped filming because I didn't think it was super interesting. But if I'm gonna explain it, because now I had other calls here, it's, from what I've heard, I've never actually had it happen to me, but if you don't have the transformer tapped right, sometimes you can get that transformer to trip. I've heard it before. Like I said, it's never happened to me before, but we had to tap into 230 because it was tapped in for 208, and that wasn't a 208 system. And then we had a jumper. Now I'm trying to think. Like I said, it's not brand new, like within the past like 2 years or anything, but it's new. I will look up the photos that I have because it was from before my channel and stuff. We replaced the motor. It's like some sort of DC type of motor. Like, forgive me, I don't know the proper names. I don't do or I don't get too technical on the AC side. I'm more on the refrigeration side. So we replaced that motor. It's a different kind of blower motor because it had voltage, the DC voltage, but it never came on. We put the new one in. It worked perfectly. Since then, I don't think I've touched it personally. Now, one of our guys could have. I need to check that, but that jumper that it had was a wire from the coil, I'm assuming to jump the second stage, and it had yellow connectors. I rarely use yellow connectors, especially if I'm doing like short jumpers. I like to use the standard smaller size. I hardly ever use those unless it's a thick gauge wire. So even when I pulled it out, it came out of the connector. If I had to use it again, I would have to redo it. But I'm assuming somebody, because when these get installed, somebody always, or companies always jump out the stages. I believe it has a 2-stage thermostat. That's usually the reason why they jump it out. But this one I think had a 2-stage thermostat, so it should have just been wired 2-stage, or for 2-stage. So they usually jump out the second stage. They already had it jumped out at the board. Y1 to Y2 jumped out, but the board usually still stages them on. Even if they're both calling, it won't turn them both on right away. So I'm assuming they jumped the gun because they both didn't come on and they tried to jump it. Now, I don't know how long it's been working like that for. Like I said, I don't recall doing that myself. I don't usually do that kind of stuff, but I have jumped them out before, whether it be at the coil, straight from the thermostat wiring, like for whatever reason to get them by if the board is acting up. But if they have it jumped out at the Y1, Y2, we don't need that other jumper. So I took it out. First stage came on. A few minutes later, the second stage came on and everything worked fine. Nothing tripped. And I'm here at the end of the day, and it's still, that was from this morning, still working fine. So like I said, fixed the tap on the transformer, removed that extra jumper that it had. Everything's fine. Didn't have any other shorts or anything. Contactors ohmed out fine, so I'm not going to deal with changing anything out at the moment. I will recommend maintenance because I can guarantee you those coils they're not plugged up. We don't get blankets of stuff here, but there is a lot of construction. So if we run water through, I'm pretty sure it's going to come out black. So they do need maintenance. I'm not going to do that on this kind of call. I will recommend it, and if they want to come out, we'll just take care of all of them. That way they have maintenance done on all of them.